Up to this point, everything we've dealt with has dealt in the Cartesian coordinate system where there's an X and a Y. We're going to move now into what's called the polar coordinate system that serves as a way to locate points with a slightly different expression of where those points are. Both points are centered at the origin. However, in this case, instead of telling us how far left or right and up and down we move, we tell ourselves what angle we go around at and how far out our radius goes. In other words, if you think of it as the origin, and this is our polar axis as opposed to the x-axis, we need to know what angle to go around the origin and then what distance to travel out from the origin. A couple of examples here. Notice here we have not moved but a degree of pi around. And then once we get that far out in degrees, we're moving out a distance of 3.5. So our point would be 3.5 comma pi. In this case, we've moved pi over 3 degrees, which is our theta, and our radius has a length of 2, our r value. And in this case, we've gone around 5 pi over 3 with a length of 3. So r is 3, theta is 5 pi over 3. An important thing to note is while x and y in the Cartesian coordinate plane give us a unique description of the point, there are a variety of ways to describe things in the polar coordinates, as indicated by our understanding of trigonometry. Notice here, we're plotting the same points, but instead of going pi degrees, we're going 0 degrees, and then in the negative r direction. So 0 degrees, positive 3.5 would put us here, but because they've put a negative here, we end up in the same place, negative 3.5, but theta is 0. The points are the same, different description. Here, theta is 7 pi over 3, and r is 2. Again, just a different description of where we are, but we end up in the same location. And last but not least, we can make our theta a negative pi over 3 instead of 5 pi over 3, and our radius is still 3, puts us in the same location. Looking at an example of plotting in the polar coordinates, remember we have r, theta. So if we look at these 3 examples here, we are going to go 3 pi over 4, which puts us in the second quadrant, and then we're going to have a length of 2. You need to know those radians and how far you travel. For B, we are going to go negative 5 pi over 2 in that direction. So we travel negative 2 pi and then another half pi with a length of 3.5. And then for choice C, our theta is 4 pi over 3, which brings us here. But then the negative tells us that instead of traveling in this direction, we're going to go in the opposite direction for our r.